All right. Now what we're going to do is we're actually going to look at Riemann sums and trapezoidal sums graphically. So this is your typical delta math exercise that's going on. So the directions always are going to tell you how many intervals. So 4 subintervals of equal length are used. And this is a left Riemann sum. So first, you want to find the width. So this is going to be the interval width divided by this number of subintervals. So in this case, I'm going from 4 to 0. So that will always be kind of given on your integral. That's your interval width. And there's 4 subintervals. So that's 4 over 4, which is equal to 1. Now, if I had 8 subintervals, then our width would have to go down to, 1/2. So we're actually just going to put in the width of each subinterval. And what it does is it creates the 4 rectangles. Now, if you're doing a left Riemann sum, we're going to start at the leftmost point. So what this means is I'm going to drag my cursor to the y value. So here we go. So this rectangle is going to have a height of 16. And be sure to kind of like drag this point up so you can get to that 16 height. Make it a rectangle. That rectangle goes to 12. And then this rectangle that's going to come goes to 7. And then we're just going to make sure that they become rectangles. And that is your left Riemann sum. So then it asks you kind of some questions. It says the shaded area above representing a left Riemann sum is an over approximation of the integral because, well, so it's asking why, and it turns out that since the function is decreasing on the interval from 0 to 4, taking the left point is always going to kind of give you, that higher y value. We're going to submit our answer here. And I think it's always good to kind of even just read the explanations if you, even if you get them right as well. So let's look at another example. Oh, good. This one is a trapezoid example. So this says, let f be the function graph below. So first thing first that I always like to do is I like to determine the width. So there are 4 subintervals of equal length again, and they are used to draw trapezoids whose area represents a trapezoidal approximation. So for the width, that's going to be 9 minus 3 over 4. That's going to be 6 over 4. So that's about 1.5. And it's fine to go decimal if you want. And you're just going to create trapezoids on these. So what you're actually going to do is you're just going to drag this point. There's a trapezoid. We'll just kind of drag these points up to their y values and then make them into the trapezoids. And we can actually see that this really fits the curve beautifully. You'd have to zoom in to see that you're off, to be honest with you. Well, actually, I mean, you could kind of see it's ever so slightly off. So this is a, ew, man, it's really close. This is a, looks to be a little bit of an under approximation. And we have, the concavity here. So this is concave down. So like if we're looking at like each trapezoid, so like I'm looking at a trapezoid here, and we're kind of zooming in. If we're concave up, this kind of like over approximates. Because that's our curve. And we get shade the area. But if we have like a concave down, we can see that we are ever so slightly lower in area. So we are concave down on this. And let's just do one more for charm. Let's do a midpoint Riemann sum. So for this one, it says 4 intervals of equal length are used. Draw rectangles whose area represents a midpoint Riemann sum. So like before, we need to find the width, so we're going to do 9 minus 3 over 4. So that's going to get us to 1.5 for our width. And we're just going to actually take that right up, and there is the midpoint. So it actually is really nice. It gives you the midpoints beautifully. You're just going to drag them up. And you got rectangles that do a little bit of under and overestimating each. And since it is a midpoint, you're not required to get into the nitty-gritty analysis. And there we have it. So I think it's kind of neat that you actually get to practice visualizing them a little bit.